Alright, this is a special lesson. I needed to head home today, not feeling very well, but I wanted to record this lesson so each period will at least be able to have a lesson and not get behind. So I'll be back tomorrow. Today we're just talking about isosceles and equiangular triangles. So I'm going to write out the notes as we go, so we'll go and keep up with how I'm writing these out. Basically, an isosceles triangle has these two base angles that are congruent. They're the exact same angle here, okay? Because the base angles are the same, and you might think about this, if you have two hands, right? We have two angles that are congruent. As you bring them together, right, you make the isosceles triangle. Because the base angles are the same, we also know that my index fingers are the same length. So what we can deduce from this is that if we have the base angles that are congruent, which they are, then the opposite sides are also congruent. So looking at that, we call these opposite sides, we call them just our legs. This is our vertex angle. And sub, if you're just noting, if students need more time to copy the notes, go ahead and pause at any time. Just keep checking on that. So what do we know? What do we know? What we know. Okay. Let's see. That the base angles are congruent and the legs are congruent. Okay. So thus, that's not an H. Thus, we come up with what's called the isosceles triangle theorem. So with the isosceles triangle theorem, basically what we're saying is if two legs of a triangle are congruent, then the angles opposite the congruent legs are congruent. Basically, this is just a formal way to note everything we saw up here. So again, just like yesterday, when we know that two things are congruent, we can relate the values or the expressions and figure out the actual measurements. So just like yesterday, this is just basically another breakdown of how things are congruent within triangle shapes. In this case, it's just an isosceles triangle. So an isosceles triangle theorem, if two legs of a triangle are congruent, so here's the legs, then the angles opposite the congruent legs are also congruent. There's also the converse. The converse is just looking at what the opposite means. So if the two legs of a triangle are congruent, then the angles opposite those congruent legs are congruent. We can think of it the other way. And that's basically saying if two angles are congruent, then opposite legs are congruent. It's just the other way around. Sometimes you need the converse because if you're making a proof statement, you need to have this option as well, because you might be proving that, well, I know information about the legs, so that tells me what these base angles, that they're congruent. Or I know about the base angles, so then I know that the legs are congruent. So it's pretty straightforward with that. Let's do an example problem. So again, no need to have perfect triangles. Here we go. We got this, ABC. And with this, let's say that, actually, let's say that we don't know. Go ahead and erase those base angles being congruent. But what we know is that this angle is 4x degrees. This angle is 6x minus 36 degrees. Right? So what we know from this, we can deduce that these two legs are congruent. So based on the converse of the isosceles triangle theorem, if two angles are congruent, then the opposite legs are congruent. And actually this one we figure out about the angles based on the actual theorem. If two legs of the triangle are congruent, then the angles opposite the congruent legs are congruent. So, I mean, it's just looking at what an isosceles triangle is. Two of the sides are congruent, so we know that those base angles have to be congruent. So what do I do here? I know that these two measurements are the same. So if these were just values instead of expressions, if I knew that this was 30, then this would be 30. Actually, this would be more like 60, that would be 60. Okay? So because we're relating to congruent angles here, and we have these expressions, what we'll do is we'll make them equal to each other. All right, let's put the 36 over on the left side, put the 4 over there. So all I did was add 36, get it over there, subtract 4x, move it over. And from there we get x is 18. So again, this is not the end. I can't put my marker away. I need to go ahead and finish this up. Basically what I need to do is go back, take my x, put it in these two expressions and figure out what the actual measurement is. 4 times x, 4 times 18 is 72 degrees. So here's the thing. For this, we may have been asked just to find x. But if I'm trying to figure out what this angle is, what do I know about angle B and angle C? What do these tick marks show us? So they show us that they're congruent. So if I plug in my x value here, I better get a 72. Let's see what we get. 6 times 18 minus 36. What is that? That's 108 minus 36. That is 72. Good. So from that, just like yesterday, just like this entire week, we know information about the isosceles triangles. From there, we can relate values or expressions in the exact same way from these theorems. Again, these theorems are just the arguments. So if I looked at this and I had these tick marks, just deductively you could reason that, well, the base angles for an isosceles are the same, so I can relate my expressions or values. But the actual argument, when we get into doing some proofs, this would be the reason. My statement and all this working out here is based on this reason, that the isosceles triangle theorem relates the legs and the angles in that way. Okay, so sub, go ahead and pause right now. I'm going to go ahead and erase this and move on to equiangular triangles. So pause right now, please. All right, we're back. So we were just talking about isosceles triangles. Isosceles have two sides that are congruent and two base angles that are congruent. Equiangular is just saying that all of the angles are the same. So again, just think to yourself, what do all the angles of a triangle add up to? What was that? They all add up to 180, right? So all the angles add up to 180. So if we have three angles that are congruent, that are the same, what do you think each angle adds up to? All right. So each of these angles, I'm just going to go ahead and write out a little bit more here. We have just do a color you can see. We know that we have equiangular. Because they all add up to 180, we know that each of these is 60 degrees. 60 degrees, 60 degrees. Okay. So again, just like the isosceles triangle, you need that theorem to be able to use this and apply it. Equiangular. Equiangular triangle theorem is just going to say that if a triangle is equiangular, then it is equilateral. All right, turn to your neighbor just for 10 seconds. What do you think equilateral means? And think about this based on the isosceles triangle. We knew that if two angles are congruent, then the opposite sides are congruent. So just chat with your neighbor, maybe about 10 seconds. What does equilateral mean? That might be too easy of a question, so I'll bring you back. I'm just pretending you're in class. All right, here in class talking to myself. All right, so looking at this, if a triangle is equiangular, then it is equilateral. Equilateral. Lateral is talking about the sides, so if the angles are all congruent, then the opposite sides have to be the same exact value. Okay. So all these sides are also congruent because we know as we open up an angle, the opposite side arrives at a finite measurement. And because all the angles are going to open up the exact same, we know that those opposite sides have to be the same length. So this is the same vice versa. You know, I could say that vice versa. Which when I say that, I'm just meaning if a triangle is equilateral, then it's also equiangular. If a triangle is equiangular, it's also equilateral. It's just basically saying that the opposite also applies. So if I'm looking at this, let's see. Let's go and pause for just one moment. All right, we're back, and here's the sample, our example problem for equiangular equilateral. So we're going to have a situation here. And we know we're just given that this is equilateral. So, okay, we know that all the sides are the same. So what do we know about the angles? If the sides are all congruent, then the opposite angles have to be the same as well. We're also told that this outside angle is 11y minus 23 degrees. And we're told that this one here is 4x plus 24 degrees. Okay. Let's call this A, B, C. And we'll go ahead and say that we're looking for angle A. So find the measure of angle A. All right. So with that, what I want to look at this and say is, if this is 4x plus 24, then so is that. Because those angles are exactly the same, they're congruent. I know that this is 4x plus 24, that's 4x plus 24. Now, what do we know about angles that combine to make a straight flat line here? So what do we know about this angle right here? Think about opening the book. You open the book all the way. What kind of angle are you creating? You're creating an angle that is 180 degrees. So this side over here, this angle, plus this angle make that straight line. So we know that those two must add to 180 degrees. All I'm going to do is add them together. Here's one of the angles, that's the interior. And then we're adding to it that exterior angle on the other side. Okay. So let's go ahead and work this out. 180 is equal to 15, oh that's y. Hold up, I'm going to go to pause just for a moment. All right, so actually I think that for this, we're going to find the measure of angle A, but first we have to find, or let's go ahead and change this up a little bit. I'm sorry, I'm not feeling great, but we're going to go ahead and let's find x, and let's find y. So my approach to this, I'm still going to use this idea that they make 180, but I'm going to take a pause here, and I'm just going to look at each side. So I'm going to go ahead and figure out 4x plus 24, that's the internal angles, and really if I want to be thorough, I could say that it's this as well. Hey, what's up? I'm just recording the lesson. I'm not feeling well, so I'm recording at home. So I'm talking myself in here. All right, so we know each angle is 4x plus 24, and it's equiangular. So we know that equilaterals are also equiangular. So all these, each of these, if they add up to 180 and they're all the same, they must each be 60. So what I'm going to do is I'm going to say 60 is equal to 4x plus 24. This is going to help me find my x value. Subtract the 24 over, we get 36 is equal to 4x. So we get x is 9. All right, found our x. Now the reason that I kept this here and just kind of worked out what x was is now we can plug in our x, and all we'll have left over in this entire equation is our y value. So let's go ahead and do that. 180 is equal to 4 times x, 4 times 9, 36, plus 24. plus 11y minus 23. Yeah, don't be intimidated if we have a lot of terms. It's no big deal. All right, this one's easy. 24 minus 23 is 1. 36 plus 1 is 37. So all I did was combine all of my constants there. 7y. Let's go ahead and subtract 37 over. When we subtract 37 over, we get 143. Remember the 11 trick. When you have 11 times 13, you take the 13, 1 and 3, then you add them together, and you get 143. So just remembering and looking and seeing, they have an 11 here, we're going to have to divide. I wonder what y is going to equal. I just kind of used the 11's trick and figured that one out. So we're going to divide by 11 both sides, and we get 13. So we got y, we got x, and all together, if I plug this y back in, it would all combine to give us 180. So what is this actual measurement out here? What is the angle measurement here? We already knew that this had a value that was going to be connected to it being equiangular. But what is this outside angle out here? So I'll give you 10 seconds. Go ahead and talk to your neighbor. What is the outside angle over here? How could we possibly figure that out? All right, 10 seconds. Hey, what's up? I'm
got a lot of marketing.
Yeah, I know.
Yeah.
I'm actually recording because I'm feeling sick, so I'm recording at home.
Okay.
So I'm just talking to myself, like normal. I'm going to pause because I want to ask how your game was. All right, we're back. So I was asking, what is this exterior angle measurement? And the way that I would approach this, actually, let's see, raise your hand. Raise your hand if you have insight about this, and you could share with the group. So go ahead and go and pick on somebody. Pick somebody out that can help us figure this one out. So again, I know that if two angles create a straight line, a horizontal line, then they add to 180. So because this is equiangular, this is 60, has to be the same. They're the same angle. 60 and 60. All the angles in the triangle out to 180, so 60, 60, 60. So if this is 60, that's really saying that we have 60 over here. So 60 plus, this is the other way around. There we go. 60 plus what gives us 180? It's 120. So we know that this over here is 120 degrees. And that makes sense, really, because that's what we basically figured out here. We knew that the two angles had to add up to 180. So it's a bit of a roundabout, but that's how we get to that conclusion. So that is it for today. Let's see. If you were planning on making up a test, you can do it tomorrow, Friday at lunch. Tomorrow we will have a clicker / game that I'll come up with. Yeah, sorry that I'm not feeling well, but I will be back tomorrow. All right, get going on the classwork. Page 173 in the workbook, numbers 1 through 10. And have a great day. All right, take care.